Hello, I am Rakib, presenting my work PC-SRGAN, Physics Informed Generative AI for Scientific Simulation. Now, why do we need simulation? First of all, we'd like to quantify underlying scientific process, and it is important in various areas. Now, the problem, the simulation is too expensive numerically. That means it takes a lot of time and higher configuration. So what we can do on that? We know super resolution is an image processing tool that increases the resolution of an image from a low resolution to high resolution. What if we can estimate the high resolution simulation from the low resolution one? Because low resolution simulation takes less amount of time and less amount of computational power. So we model it as an image super resolution problem. And for that, of course, we know there are traditional AI methods to do this super resolution. But this may not be enough when we use that for scientific simulation because they lack physical meaningfulness. So to solve this, we propose physics-enabled image super resolution. Now, this physics-enabled method is physics-enabled generative AI. So to demonstrate that generative AI, this particular diagram shows with traditional generative adversarial network or GAN architecture, where we have this low resolution image and we have this high resolution reference image AI model will learn to generate. So in a traditional generative adversarial network, we have these architectures common, like a generator or a discriminator. But our key innovation is this cost function using physics. So we impose the laws of physics so that it maintains the laws of physics and it is useful in practice, which have been published in a top journal, IEEE Transaction on Pattern Recognition and Machine Intelligence. Now, in terms of result, how it improves? So on the top row here, we see this is the input image, and this is the reference image that we would like to generate. And this is on this top right corner, this is what we have received from the model. We see this is quite close to the reference that we have. We see that our method works, but what about quantitative performance in established evaluation metrics? Our method performs better compared to the standard approach that we have currently. So we test our method across different configuration, different data sets, as you can see, and we specifically use two different data configuration, which have further three different boundary type. And here we compare our method PC-SRGAN with an existing GAN-based method SRGAN, which we can also say non-physics based method. And across these multiple evaluation metrics, our method consistently outperforms the existing approach. We further do additional analysis. Specifically here, this graph shows that our method is data efficient. That is, this physics-enabled SRGAN beat the performance of SRGAN, which is an existing approach, with only 13 to 17.7% of training data. Instead of a traditional simulation method, can we use our AI method to estimate the higher resolution simulation and continue using that? We see that it generates physically meaningful result that is useful for scientific simulations. Thank you.